Hi, this is Jacob's Algebra, Chapter 10, Lesson 5. The title of this lesson is Factoring the Difference of Two Squares. So if we are shown something where we see two square numbers and we're subtracting them, like 9 minus x squared, we can use our difference of two squares formula to know what this is. 9 is the square of 3, so we can write that as 3 squared. Our x is already written in the form of a square. So this is 3 squared minus x squared. Well, if you remember, we had a lesson where we learned that a plus b times a minus b equals a squared minus b squared. So to get the difference of two squares, we multiply the sum of the terms by the difference of the terms. So 3 squared minus x squared is going to be 3 plus x times 3 minus x. So all we do is we take the first number that's squared and add it to the second number that's squared. And then we multiply that by the first number that's squared minus the second number that's squared. What if we had something like 2x squared minus 32? Well, those aren't square numbers, but notice that the 2 and the 32 are both even numbers. We can factor that out. If we factor out the 2, 2 times what is 2x squared? That's going to be x squared. 2 times what is negative 32? Well, that would be negative 16. Now, inside of the parentheses, we do have two square terms. We can rewrite this as 2 times x squared minus 4 squared. And we know how to factor that. If you have the difference of two square numbers, then what we're going to do is write this as our first number plus our second number. Whoops, sorry, I started to write a b there. Our first number plus our second number times our first number minus our second number. Now this is the number that's being squared, not the square. So 2x squared minus 32 can be factored as 2 times x plus 4 times x minus 4. So that's basically the gist of the lesson. It's to be able to go from a squared minus b squared to a plus b times a minus b. Or if you're given a plus b times a minus b, to know that when you multiply that out, you're going to get a squared minus b squared. So if you're starting off with two terms that you're taking the difference of, and they can both be written as squares, you need to first write each of them as a square. So if you have 16, you would need to write it as 4 squared. Or if you had 36, you would need to write that as 6 squared. Or if it was something like 36x to the fourth, that would be 6x squared quantity squared. So you need to be able to write your terms as a square. If you can write both terms as a square and you're taking the difference of them, then you can factor them out by adding your two terms and subtracting your two terms and multiplying those together. So the first one we're going to look at is number 4. And we're going to work just a couple of these sections. Number 4, part C, is 5x plus y times 5x minus y. And when we multiply those out, notice we have the sum of two terms multiplied by the difference of two terms. What that means is that we can just square the first term, 5x, and we're going to square it, and subtract the square of the second term. The second term is y. So we take our y and we just square it. What is 5x quantity squared? Remember, we have to square the 5 also because it's inside of the parentheses. So 5 squared is 25. The x squared is just x squared. And then we subtract y squared. So that's how we get 5x plus y times 5x minus y. We can also work this out with our grid. So if you want to write the grid, I'll just stop this and write it real quick. So now you see the grid written out with 5x plus y across the top and 5x minus y across the side. 5x times 5x is 25x squared. 5x times y is 5xy. 5x times negative y is negative 5xy. And negative y times y is negative y squared. So we would have 25x squared. Our 5xy and our negative 5xy add to 0. and then we have a negative y squared, so that we end up with 25x squared minus y squared. Okay, so let's hop down and do part E. Part E is x minus y squared times x plus y squared. Okay, what we need to do is we take our first term and we square it. Our first term is x, and we're going to square it. Then we're going to write a minus, and we'll write our second term, which is y squared, and we're going to square that. So what we end up with is x squared minus y to the fourth. Remember, when you raise a power to a power, you multiply the exponent. So this is going to be 2 times 2 is 4. So we get x squared minus y to the fourth. Then we're going to work one more part from number 4, which is 1 plus xy times 1 minus xy. Again, we have the sum of two terms multiplied by the difference of two terms. So what we're going to get is the difference of the squares. Our first term is 1, so we're going to square that, and then we're going to subtract the square of our second term, which is xy. 1 squared is just 1. Xy squared, we have to raise both of these to the second power. That's going to be x squared y squared. So for number 4, part F, it's 1 minus x squared y squared. Number 4 is just like number 10 that I assigned for homework. So it's just multiplying out what you're given. It's just that since everything that you're given is the sum of two terms multiplied by the difference of two terms, we can use our shortcut formula of a squared minus b squared. So now let's move on to the next problem, number 5. It says, if possible, write each of the following as the square of a monomial. So they give you a bunch of different things that you can write as a square. So I'm going to pause this and write these on the screen real quick. Okay, so here are just a few of the terms that you're given for number 5 that you're supposed to write as the square of a monomial. So if you're given x to the 8th, can that be written as a square? Yes, it can, because 8 is an even power. Even powers can be written as squares. This would be x to the 4th to the second power, because 2 times 4 is 8. When you raise a power to a power, you multiply the exponents. Okay, then we have 36x. Well, 36 can be written as a square because that is 6 squared. But x is to the first power. We cannot write an odd power as a square. So that one can't be done. You would write not possible. Okay, x to the 36. This is an even power, so this can be done. X to the something power, and we're going to square it. Remember, when you're raising a power to a power, we multiply the exponents. What do we have to multiply by 2 to get 36? That would be 18. So x to the 18th and then raised to the second power is x to the 36th. Then we have 9x to the 4th. Well, 9 is the square of 3. X to the 4th, that's an even power of x. What do we have to raise x to so that when we square it, we'll get 4? 2 times what is 4? Well, that would be a 2. So the 3 squared will give us the 9. The x squared will give us the 4. Okay, the next one is 4x to the 9th. Notice 4 is a square number, so we could write that as 2, and then we're going to square it. The x to the 9th, though, that's an odd power of x, and because that's an odd power, we can't write that as a square. So for this one, we would need to say not possible. My writing is lovely. This up here is also not possible. Okay, then we're down to 16x squared y squared. 16 is a square number. That's 4. So we can write that as a 4. And we're going to put that in parentheses and square it. The x and the y are both raised to even powers. What do we have to multiply 2 by to get 2? Well, that would just be 1, x to the first power. What do we have to multiply 2 by to get this 2? Again, that would just be 1. So 4xy, quantity squared, is going to be 16x squared y squared. Then our last one, 100, what do we have to square to get 100? Well, that would be 10. What about the x? What do we have to square to get x to the 100th power? What power do we have to raise the x to? Well, 2 times what is 100? That's going to be 50. So 10x to the 50th, quantity squared is going to give us 100x to the 100th. So in this second column, you can see everything that was in the first column written as a square, except for the two that are not possible to write as a square. If your variable is to an odd power, you cannot write it as a square. Okay, so that was number 5, which is just like number 11 that I assigned for homework. So now we're going to look at number 6. Okay, so for number 6, you're given 4 different diagrams that are worked out. I'm just showing one of them. And the problem says, express the area of each of the following figures, both as a polynomial in simplest form and as the product of 2 binomials. Well, they've already done the hard part for you. They already did the work. All you have to do is write down what they've shown you as a math problem. So we need to write this as the product of binomials. So that means we're going to write 2 pairs of parentheses. And inside the parentheses, we're going to put the 2 factors. Our 2 factors are what we have on the top and what we have on the side. So on the top, we have x minus 3. And what we have on the side is x plus 3. Those are the things that were multiplied to get everything that's inside of the grid. So what we write next is the polynomial in simplest form. So we have x squared. Negative 3x plus 3x is 0, so there is no middle term. And then we have a minus 9. So when it says express the area of each of the following figures, both as a polynomial in simplest terms, this is the polynomial in simplest terms, and as the product of 2 binomials, this is the product of 2 binomials. You just have to take the diagram that's given and write it as a math problem. So number 6 is not too horrible, and this is just like number 12 that I assigned as homework. Okay, so we're skipping number 7 because number 7 is not at all like number 13 that would have been assigned as homework, but number 13 is one of these awful circle diagram problems, and those I find a real pain because I don't think they're very helpful. So we're going to skip that one and move on to number 8. Number 8 says factor each of the following polynomials as completely as possible. So we're going to do a couple of these. Let's start with 8f. 8f has 8x squared minus 4. Well, 8 is not a square term, so we can't write this as the difference of 2 squares. But if we look at both of our terms here, we can see that they both have even numbers. We have an 8 here and we have a 4 there. And the greatest common factor there is actually 4. So let's factor out the 4. So we can write this as 4 times something. 4 times what is 8x squared? Well, that would be 2x squared because 4 times 2x squared is 8x squared. 4 times what is negative 4? Well, that would have to be a negative 1 because 4 times negative 1 is negative 4. And that's really as far as we can take this because we still don't have square numbers inside of our parentheses. The 1 is a square number and the x squared is a square number, but we can't write 2 as a square number. So 4 times the quantity 2x squared minus 1 is all that we can do with this one. So let's move on to part G. Part G is 5x squared plus 20. Okay, we don't have the difference of 2 squares here, so we can't use that handy formula. But notice that the coefficient of the x squared and our number here are both multiples of 5. That means we can pull out 5. So I'm going to write a 5 here. What do we have to multiply 5 by to get 5x squared? Well, that would be x squared. What do we have to multiply 5 by to get 20? That would be a positive 4. Now, we can't factor this any further. We know how to factor if this was x squared minus 4, because that could be factored as x plus 2 times x minus 2. But we can't factor x squared plus 4. That's as simple as it goes. So we're going to move on to part H. Part H is x to the 4th minus 49. Okay, both of these can be written as square numbers. X to the 4th can be written as x squared squared. 49 can be written as 7 squared. So we can write this as x squared plus 7 times x squared minus 7. And we will continue with a couple more parts from number 8 and with a couple parts from number 9 in the next video. Number 8 is just like number 14 that I assigned for homework.